Which factor most directly determines whether microbes survive during instrument transport from the ore to decontamination? A. The color of the transport cart. B. The physical distance traveled. C. The presence of retained moisture and organic soil. D. The weight of the instrument tray. Answer: C. Moisture and organic soil create an ideal environment for microbial proliferation. Even short transport times allow bacteria to multiply dramatically when bioburden is not allowed to dry. The airflow in a decontamination area must be maintained under A. Positive pressure relative to clean areas. B. Negative pressure relative to clean areas. C. Equal pressure to clean areas. D. Neutral pressure with intermittent exchange. Answer: B. Negative pressure prevents contaminated aerosols from migrating into clean or sterile areas, maintaining strict separation of workflow as required in Chapter 5. Which cleaning action removes microbes primarily by mechanical displacement rather than chemical destruction? A. High-level disinfection. B. Enzymatic soaking. C. Manual scrubbing with friction. D. Steam sterilization. Answer: C. Manual mechanical friction breaks biofilm, loosens bioburden, and physically removes microbial cells, reducing the microbial load before disinfection or sterilization. What is the most important first step when receiving contaminated instruments in decontamination? A. Donning full PPE before handling items. B. Removing biological indicators. C. Immediately counting each instrument. D. Placing items in the washer. Answer: A. Infection prevention begins with staff protection. PPE is essential before touching any contaminated device to prevent mucous membrane and skin exposure. A biofilm becomes significantly more resistant to cleaning when it reaches which stage? A. Initial attachment. B. Early colonization. C. Maturation stage. D. Dispersion stage. Answer: C. Mature biofilms have complex extracellular polymeric matrices that protect bacteria from chemicals, making them extremely difficult to remove unless addressed early. Which microorganism is most commonly associated with contaminated endoscopes due to its biofilm forming capability? A. Streptococcus pyogenes. B. Pseudomonas aeruginosa. C. Clostridium tetani. D. Escherichia coli O157. Answer: B. Pseudomonas thrives in moisture-rich lumens and forms robust biofilms, making it a high-risk pathogen in improperly reprocessed endoscopes. Why must enzymatic detergents remain within their specific temperature range? A. High heat deactivates the enzyme. B. Low temperatures cause explosive foaming. C. Enzymes neutralize at pH extremes only. D. Water hardness has no effect on enzymes. Answer: A. Excessive heat denatures enzymes, preventing them from breaking down blood and organic proteins essential for effective pre-cleaning. Which practice most effectively prevents cross-contamination between clean and dirty work zones? A. Color-coding scrub brushes. B. Posting instructional signage. C. Physical workflow separation. D. Wearing ear protection. Answer: C. Infection prevention in SPD relies on dividing space into distinct zones with unidirectional flow to prevent accidental microbial transfer. Decontamination sink compartments are required because they allow A. Water to remain stagnant for enzyme activation. B. Segregation of wash, rinse, and soaking phases. C. Avoidance of PPE during cleaning. D. Faster drying after cleaning. Answer: B. Dedicated compartments prevent chemical cross-interference, ensuring each phase supports microbial reduction. A technician notices a cloudy appearance on instruments after cleaning. This indicates A. Loss of chromium oxide layer. B. Water impurities such as mineral deposits. C. Excessive lubrication. D. Contamination by disinfectants. Answer B. High mineral content leaves a cloudy film that can interfere with sterilization and must be addressed with treated water systems. Which method reduces microbial aerosols during manual cleaning? A. High-pressure spray. B. Agitating brushes dry. C. Keeping instruments submerged. D. Adding extra detergent. Answer C. Submerged scrubbing prevents aerosolization of contaminated droplets, lowering airborne infection risks. The most critical PPE barrier for preventing mucous membrane exposure is A. Shoe covers. B. Face shield. C. Hair bouffant. D. Lead apron. Answer B. Face shields protect eyes, nose, and mouth from contaminated splashes, high-risk exposure sites, and decontamination. Which action compromises infection control during instrument transport? A. Closed, leak-proof containers. B. Labeled biohazard bins. C. Transporting instruments uncovered. D. Following a marked path to decontamination. Answer C. Uncovered instruments can aerosolize pathogens, drip fluids, and expose staff to infectious material. Soil drying on instruments significantly increases risk because A. Dry instruments damage cartwheels. B. Dried soil attracts airborne dust. C. Desiccation binds proteins to surfaces. D. Instruments become less magnetic. Answer C. Drying makes bioburden extremely difficult to remove, requiring far more aggressive cleaning and risking sterilization failure. Which factor most influences disinfectant kill time? A. Microbial load on the item. B. Temperature of the room. C. The brand name of the disinfectant. D. The container size. Answer A. Higher microbial loads require longer dwell times. Overloading disinfectants reduces effectiveness and allows surviving pathogens. Splashing during sink cleaning is most likely caused by A. Excessive water pressure from the faucet. B. Using a low water level. C. Insufficient detergent. D. Using long-handled brushes. Answer A. High pressure creates turbulence, increasing aerosolization and splashing of contaminated fluids. The greatest infection prevention concern with lumen instruments is A. Poorly formed packaging seals. B. Incomplete internal contact with detergents. C. Incorrect storage shelf height. D. The material color of the lumen. Answer B. Lumens trap debris and biofilm. If internal surfaces don't fully contact cleaning solutions, hidden microbes survive. What is the purpose of pre-rinsing with cool water? A. To activate disinfectants. B. To lubricate joints. C. To rapidly sterilize the surface. D. To prevent coagulation of proteins. Answer D. Hot water coagulates proteins, making them adhere tightly to metal surfaces and harder to remove. Hand hygiene is essential in decontamination because A. Gloves may tear or become contaminated. B. Alcohol increases glove durability. C. It prevents slipping on wet floors. D. It removes instrument oil. Answer A. Gloves provide a barrier but can fail or become contaminated during high-risk tasks. Hand hygiene prevents unintended microbial transfer. The most effective way to prevent recontamination of cleaned instruments is A. Double wrapping trays. B. Maintaining positive airflow in clean areas. C. Wearing thicker gloves. D. Using ultrasonic cleaners. Answer B. Clean assembly requires positive pressure to keep contaminated air from entering, reducing airborne microbial contamination. Why must contaminated instruments be opened, unlocked, and disassembled before cleaning? A. To expose all surfaces to cleaning solutions. B. To reduce noise in the sink. C. To count parts more easily. D. To prevent water spots. Answer A. Infection prevention depends on solution contact. Closed joints trap debris that can protect microbes. The primary purpose of using enzymatic foam sprays in the OR is A. To prevent drying of bioburden. B. To sterilize instruments immediately. C. To lubricate surfaces. D. To disinfect transport carts. Answer A. Foaming agents keep soils moist, preventing the formation of biofilm and protein bonding prior to decontamination. Which step is required before loading items into the ultrasonic cleaner? A. Drying items completely. B. Removing visible debris manually. C. Heating ultrasonic water to boiling. D. Adding bleach to the basin. Answer B. Ultrasonic cavitation cannot penetrate heavy bioburden. Manual removal is essential for infection prevention. Pathogens are most likely to survive in cleaning brushes if A. Brushes are soaked in alcohol. B. Brushes are stored upright to dry. C. Brushes are reused without disinfection. D. Brushes are color-coded. Answer C. Reusing contaminated brushes spreads microbes and biofilm from one instrument to another. Why is water hardness a concern during cleaning? A. It increases evaporation. B. It binds to detergent molecules, reducing cleaning efficiency. C. It increases window condensation. D. It makes PPE more slippery. Answer B. Mineral ions interact with detergents, preventing them from breaking down organic soil effectively. Which disinfectant factor most affects its microbial kill spectrum? A. Concentration accuracy. B. Odor level. C. Bottle material. D. Label color. Answer A. Incorrect dilution weakens germicidal activity or increases toxicity. Proper concentration is essential to kill pathogens consistently. Biofilm begins forming. A. Only after 24 hours. B. Immediately upon exposure to moisture and nutrients. C. Only in lumens. D. Only after sterilization failure. Answer B. Bacteria begin attaching to surfaces within minutes. Delay in cleaning exponentially increases difficulty of removal. Why are prions especially problematic in infection control? A. They are viruses that multiply quickly. B. They are destroyed by warm water rinse. C. They dissolve easily in detergents. D. They resist most standard sterilization processes. Answer D. Prions are misfolded proteins highly resistant to heat and chemicals, requiring special reprocessing protocols. What does water turbidity in sinks indicate? A. Proper enzyme activation. B. Fresh chemical activity. C. A harmless visual effect. D. Accumulation of suspended soil and microbes. Answer D. Cloudy water signals microbial growth and organic load, reducing cleaning effectiveness and requiring immediate change. Which best describes the purpose of air exchanges in decontamination? A. To cool the workspace. B. To replace contaminated air with fresh, filtered air. C. To reduce noise. D. To keep floors dry. Answer, B. Air exchanges reduce airborne microbial concentration, preventing infection spread through aerosolized particles. PPE must be removed in a specific order because A. Removal order prevents self-contamination. B. It preserves PPE for reuse. C. It saves disposal space. D. It reduces static electricity. Answer, A. Incorrect removal causes contaminated surfaces to contact skin or mucous membranes. Which factor most affects ultrasonic cavitation effectiveness? A. Temperature of the room. B. Thickness of the sink walls. C. Type of PP used. D. Absence of trapped air in the solution. Answer, D. Air interferes with cavitation waves. Degas solutions maximize cleaning efficacy. Contaminated storage of endoscopes primarily increases risk of A. Loss of color coding. B. Microbial biofilm regeneration. C. Broken valves. D. Excessive lubrication. Answer, B. Even after high-level disinfection, damp surfaces and improper storage promote rapid biofilm redevelopment. What is the infection risk associated with poor instrument lubrication practices? A. Lubricant attracts fungi. B. Lubricant speeds rusting. C. Instruments become magnetic. D. Excess lubricant traps debris. Answer, D. Over-lubrication creates a sticky surface that traps organic particles, allowing microbial retention. Why is water temperature important during detergent activation? A. Hot water turns enzymes acidic. B. Each detergent has a specific activation temperature. C. Warm water destroys stainless steel. D. Cold water stains instruments. Answer, B. Incorrect temperature may deactivate detergents or reduce soil breakdown efficiency. Which infection prevention step reduces pathogen survival before instruments reach decontamination? A. Initial point-of-use cleaning. B. Air drying instruments in the OR. C. Stacking trays on top of one another. D. Using mismatched containers. Answer, A. Point-of-use cleaning prevents drying, reduces microbial load, and improves final decontamination results. Detergent foam is undesirable because it A. Creates a fresh scent. B. Interferes with mechanical cleaning action. C. Speeds up rinsing. D. Makes water softer. Answer, B. Foam traps soil and prevents effective contact between instruments and cleaning solutions. Which factor most determines a disinfectant's shelf life? A. Whether the bottle is transparent. B. Color of the storage cabinet. C. Noise level near storage area. D. Date of activation or dilution. Answer, D. Once diluted or activated, disinfectants begin degrading and must be used within the indicated time frame. Reprocessing single-use items threatens infection prevention because A. They deteriorate structurally when reprocessed. B. They discolor underwater. C. They require no cleaning. D. They cannot be transported. Answer, A. Single-use items cannot withstand cleaning/disinfection processes, leading to cracks that harbor microbes. The presence of blood clots on instruments after manual cleaning indicates A. The device is ready for sterilization. B. Cleaning was incomplete and microbial load remains. C. Sterilizer ran too long. D. The water was too pure. Answer B. Residual organic matter protects microbes and prevents effective sterilization. Why must cleaning brushes for lumens match the lumen diameter? A. Larger brushes increase noise. B. Incorrect sizes damage staff gloves. C. Too small brushes leave internal biofilm. D. Large brushes cause water splashing. Answer C. Undersized brushes fail to contact internal surfaces, allowing microbial survival. Splash-proof gowns are required because A. They reduce static electricity. B. They prevent penetration of contaminated fluids. C. They improve movement. D. They eliminate heat stress. Answer B. Penetration resistance protects technicians from high-risk biological fluids during manual cleaning. Poor drying in clean assembly most increases the risk of A. Rust-free storage. B. Microbial survival through sterilization. C. Lighter trays. D. Improved lubrication. Answer B. Moisture shields microorganisms from sterilant penetration, creating sterilization failures. A disinfectant used below its stated minimum contact time will result in A. Rapid sterilization. B. Enhanced drying. C. Foam reduction. D. Surviving pathogens. Answer D. Microbes require a full chemical dwell time for inactivation. Short exposure leads to incomplete kill. Why must items be fully submerged during ultrasonic cleaning? A. To prevent floating instruments. B. To avoid noise. C. To keep PPE visible. D. To allow cavitation bubbles to reach all surfaces. Answer D. Cavitation works only when bubbles can contact surfaces uniformly, ensuring microbial removal. Reusable cleaning brushes must be disinfected because A. They can rust easily. B. They retain microorganisms between uses. C. They change color otherwise. D. They require less water pressure. Answer B. Brushes trap organic material and microbes. Without disinfection, they become vectors of contamination. The most critical reason to use low-sudsing detergents in mechanical washers is A. Foam reduces pump efficiency. B. Foam causes discoloration. C. Foam eliminates lubrication. D. Foam increases detergent scent. Answer A. Foam blocks spray arms, reducing mechanical cleaning force and allowing microbial retention. What does proper rinsing accomplish in infection prevention? A. Removes residual detergents that may interfere with disinfection. B. Enhances lubricant absorption. C. Prevents discoloration. D. Increases water fill time. Answer A. Residual chemicals can neutralize disinfectants or damage instruments, compromising microbial kill steps. High humidity in clean assembly increases risk because A. It loosens wrapped packages. B. It encourages microbial growth on drying surfaces. C. It accelerates sterilizer cycles. D. It sterilizes instruments. Answer B. High humidity allows moisture to persist, creating an environment conducive for microbial survival. The best indicator that cleaning has effectively reduced microbial load is A. A shiny instrument surface. B. Absence of visible soil. C. Surface free from blood, debris, and protein residue. D. A pleasant smell. Answer C. Infection prevention depends on complete removal of organic soil. Microbes hide within biological residues even when instruments appear visually clean.